All right, 1, 2, 3, we're live. Hey guys, hope you've had a good week. Been a little bit busy still here at the observatory. Just doing all the stuff we can while getting stuff repaired and all that kind of stuff while we've got the time. So yeah, tonight we've got a bit presentation for you. Tonight we'll be talking about the history of the observatory. So it's over 120 years old, so it's got a fair bit of history, and it's been fairly important to West Australia, and particularly at the beginning of the colony and then the state itself. So I'd like to present my talk. We're not dead yet. And this goes back to the Monty Python's Holy Grail. I like my Monty Python, and once you go through the story, you'll know you'll come to understand why I named this presentation "We're Not Dead Yet." So we're in the very beginning. We were a very young colony, and we were on the rise as well. So there was rapid growth to Perth's population in the 1890s, and that was due to the gold rush that was happening in Kalgoorlie. And so we were getting a lot of money in, and it was down to this man, Sir John Forrest, our very first premier, who wanted to do some public works, and he was he really wanted to get the state up to the standard of the East Coast cities and states, because we had federation coming in 1901, and we didn't want to be the younger brother to all the other states. So we wanted to enter federation on equal terms. And so with the money that was coming from the goldfields rush, he was able to get public works buildings done. So out of this, we actually got the WA Mint, the Perth Mint, WA Museum, and we also got the observatory, Perth Observatory. And so while our main role was to make observations of the night sky, we also needed to provide accurate time for Perth. Up until the observatory was created, there was about 21 towns that had their own different time, and it was a real hassle for public transport and trains going from Perth to Kalgoorlie. It could just be that your town only got a couple of services via the train every so often, and if you were running on Perth time but the train was running on Kalgoorlie time and you were 5 minutes late, you could have been half an hour late. So that was a really big thing. And when you actually see a lot of the really old observatories, you'll notice that they're smack bang in the middle of their cities, or they at least started there. And the reason that is that not only were they making observations of the night sky, and you didn't have to deal with a lot of light pollution back when they first started, but it was also providing time for the observatory as well. If you go to the Greenwich Observatory in London, there is a huge amount of their museum is donated to actually time, and that was because there was Sir John Flamsteed was commissioned by King Charles II to turn Greenwich Palace into the observatory, because while he was interested in science, the Navy needed to know the time so that they had the edge over the other navies like the Spanish, the French and the Dutch. Also, he wanted the observatory to provide weather reports and also record seismic activities. West Australia is actually has a couple of faults. They're not your tectonic plates, but it is quite seismically active. If you come to West Australia and you go out to the wheat belt, there is the town of Meckering, which was basically flattened by an earthquake in the early 20th century. and you can even driving out to Meridian, you'll actually drive over the fault, and there's a drop down as well. So it's the observatory was needed to record seismic activities as well. So they'd had been about two attempts beforehand to actually get the observatory up and running, and they'd failed because of the financial backing. So I always like to say on the night sky tours, it's a little bit like the scene in Holy Grail where the king of the swamp, he'd built his castle, but unfortunately that sunk into the swamp. So he built it again, and that one sunk in the swamp. The third time it stood up, but it burnt down and sunk in the swamp. But it was the fourth time that stood up. And so while we were up on the third attempt, we didn't have to get to the fourth attempt. But and the reason it failed was because just basically financial backing. There wasn't enough interest in having an observatory. But in 1895, the West Australian government actually got the government astronomer for South Australia out here, Sir Charles Todd, and help advise where to actually put the observatory. And the previous attempts had the observatory in Kings Park. But he actually recommended slightly north and on top of Mount Eliza, which is just basically across the road from Kings Park. And it was a little bit higher. There wasn't as much light pollution from the south of Perth. And, you know, back in those days, you didn't have the big office towers as you did. He recommended, and he also recommended his first assistant, so William Ernest Cooke, to be to be our very first government astronomer, and he became a Sir in the end. But his first job was to actually create the foundation stone, and this is the foundation stone of the Perth Observatory. And there's some really interesting stuff here. You can see here in the top left that we've got a couple of circles of symbols, and then inside there's some more symbols, and you've got what looks like the sun. Well, the outer circle, the images there, are the signs of the constellations, and the inner circle where you've got the other symbols, they're actually the symbols for the planets, and that means. So what we're seeing, and the very, very big spiky thing is the symbol for the sun. So what we're actually seeing here is where the planets were around the sun on the 29th of September 1896, when the foundation stone was actually laid on the site at Mount Eliza, and it was Sir John Forrest who actually laid that very first very first stone. And so after he'd created it, he then created the foundation stone design. His next thing was to create the ceremony to celebrate that foundation stone, and it was a grand civic occasion. The observatory was built, and it costed the West Australian government £6,622. It was 7 months late, which, you know, for a government project, that's not too bad. And it was officially opened on the 3rd of March 1897, and it included 3 buildings. You had the main building, which is the main office building, where they actually did all the calculations. They had the women who were called computers, who would then go through all the data that was collected and calculate where the stars were and how bright. And this was actually designed by George Temple, and it's still there today. You'll notice that in the background you've got the Dumas House, which is where the state ministers and their staff work. There was also the Transit Circle building, and this housed the Transit Meridian telescope, which was used to make catalogues of the sky and also find exactly where Perth was in the in the on the Earth. It's a lot easier to find where you are in terms of latitude, because you can, if you're in the northern hemisphere, you use Polaris, how high that is in the northern hemisphere. It's a little harder to find exactly where you are south in the southern hemisphere, and to do that you need to draw imaginary lines through the Southern Cross, and from the middle point of the 2 pointers, and where those 2 lines intersect, that is where the South Celestial Pole is. And then basically you determine how high that is in the Southern Hemisphere, and you can work out where you are in terms of in the Southern Hemisphere. If you're ever lost and you've come across a stream, Bear Grylls says to follow it downstream, because usually civilizations on the coast. And so not only was the Meridian telescope used to actually catalogue stars, but it was also using catalogue of stars from the Greenwich Observatory to actually figure out where those stars were in our sky, and then they were able to calculate exactly where Perth was, and that helps with actually our time. So then they could standardize the time from where we were on the globe relative to Greenwich. And then we actually had the dome itself, and you can see this lovely dome, which was actually designed based off the Greenwich Observatory's dome and building, and it housed our Astrographic telescope, which was designed by Howard Grubb. And we chose this one because we were joining the Carte de Seal project, and there were 2 telescopes that were being used for the Carte de Seal project, and Sydney and Melbourne had astrographs. So even though Sir William Ernest Cooke, which I'll talk about later, actually went and saw the 2 manufacturers, he ended up going with the Astrograph because it was Howard Grubb was a very good telescope maker, and also Sydney and Melbourne had it as well. So so William Ernest Cooke's era begins in 1896, and it goes all the way through to 1912 when he resigns to take up the position of Government Astronomer for New South Wales at Sydney Observatory. So we actually have the observatory here at the beginning of the 20th century. You can see we've got over here, we've got the main the Transit Meridian building, the traditional dome itself building, and the office building right here. Today, the only thing that exists is the main building. To make Dumas House, they had to remove these 2 domes, which I'll go into a little bit further on. So there was also stuff that, in terms of time that we were doing, we actually, so not only did we develop Australian Western Standard Time, but then we actually had to provide that time to not only Fremantle for the time ball, because if you're out to sea, even though you can hear the gunfire for the time cannon there is a delay in you hearing that sound, because light travels faster than sound. And so they had the time ball for ships far out to sea, with their captains looking at their periscope, waiting to set their time so that they can accurately navigate the seas. And the ball would drop and they would set their clocks. And so we also provided time to the state railways, the telegraph system, and also the public clocks in Fremantle and Perth. There was also a time cannon from 1901 to 02. Someone thought this was a very good idea, and the time cannon was set up on the eastern slope, pointed towards the Perth CBD area, and would fire daily at 1 p.m. The only problem was it was scaring the crap out of people, and one person actually had a cardiac arrest. So you can notice it only lasted a year, and that was why it didn't last that long. This is some of the weather reports that Cooke had done, and you can actually see that here that we actually did this up to 1908, when the Weather Bureau of Meteorology was set up, but even then, after that, it was we actually had the site, the actual weather station, still at the observatory, and that was one of the weather sites. Even today, we actually have a weather station at the observatory, and you can actually see on the Channel 7, Channel 9, ABC, when you look at the weather reports and you see the temperature at Bickley, you can actually that's the observatory. So you can actually there's some times where I'm pretty glad I'm not at the observatory when it's really, really cold. And these weather reports were actually collated and published in annual meteorological reports, and the observatory provided the tide tables for the northwest ports and astronomical information, including times of sunrise and sunset as well. And we were invited to collaborate in a number of international star cataloguing maps and mapping programs. We did a catalogue of 420 standard stars that was published here, and the exact longitude and latitude for Perth was and of the observatory was established in quite early on in 1899. We had, and you can see here, we've got Kings Park right here. Looks a little bit different, and a lot of these trees have grown up as well. It's one of the largest parks. I think it's the largest park in the in a city, at least in the southern hemisphere, if not the world. It's very, very big. It's lovely if you come to Perth. It's a great place to have a walk through. And so one of the big things we were part of at that very beginning was the Carte de Ciel project. So we actually got the Rio de Janeiro's observatory's patch of sky. Unfortunately, they weren't able to do it, and so they gave it to us, and we did that from 1901 all the way through to 1919. The project was finished up in 1930 and incomplete, but it's still a very, very, very important star catalogue and map. It was the Carte de Ciel project wasn't it was a massive big project to map the entire southern sky because it wasn't well mapped. It was northern hemisphere was well mapped because you had so many observatories and over a long period of time. But because of sailing was so problematic back in those days, and you weren't always guaranteed to survive with all the sicknesses and that. It took a while to get all the astronomy staff down here, down to the southern hemisphere, and set up really good observatories. We were actually very, very important to the public. They actually started doing public lectures and public viewing nights as well as part of our mandate, and they were very, very popular. So much so that we actually had to get the Calvert Telescope, which you can see here, from the United States Naval Observatory. And this became the very first public telescope. And even if you come up in a night sky tour today, you'll be able to look through that telescope. It's over 110 years old. And the reason we had to get that was because the public was so wanting to come up. It was actually eating into the research time. So the government, the astronomers were complaining that, hey, we're not getting enough research done, and so they purchased this, and also in time they were hoping to get it in time for 1910 pass of Comet Halley, but unfortunately didn't actually get to study Comet Halley because not all the parts were sent out, and it's quite interesting seeing the letters going back and forth saying, hey, where are the parts? We need the parts. come on, I want the parts. And they're coming, we're trying to find them. But in 1912, Sir William Ernest Cooke resigned, and he took up the government astronomer position for New South Wales at the Sydney Observatory, and did a lot of work there. Unfortunately, he ended up having to resign. Not in. They say disgrace, but the reason he ended up resigning was that they'd promised a new observatory and it never came about, and so the government there was quite critical of Cooke. But he did a lot of he was a very important astronomer for West Australia and Australia as well. When he left, it came down to Howard Kerr-Lewis, who was his assistant, to take over. Now, his position wasn't officially filled until 1920, so he was acting government astronomer for at least 8 years or so before being promoted to government astronomer. And unfortunately, that was due to a bit of state politics. The state government had applied to appealed to the Commonwealth government to take over the running of the observatory ever since Federation. So from about 1902, there'd been repeated attempts to actually give off the observatory to them, let them handle it, and the Commonwealth government's like, no, it's okay, you guys have it. No, we want you to take it. No, I don't want it. Okay. And so in 1928, we staved off death. There was an issue between the state government and the Commonwealth government, and so the state government did the patriotic decision of keeping the observatory and running the observatory from the evil Commonwealth government. So it's we staved off our first death there. But in the meantime, even though the staff had been cut down to basically only a couple of people, Howard Kerr-Lewis was able to still get stuff done. So this is a photo of him out on the South Australian, West Australian border, using a 12-inch theodolite to survey the southern, the border of West Australia and South Australia. And he actually had done that with, this one was at Deakin, but he did that at a number of places, and also where the Northern Territory border would end up being. And this was all done in conjunction with the South Australian government astronomer as well. In 1921, they used wireless radio time signals and other methods to position the Northern Territory West Australian border as well. In 1922, there was a very, very important eclipse that was going to happen. This was the first major total solar eclipse since the Great War, and the Wallal Expedition was set up to test Einstein's newly proposed theory of relativity. And so there'd been previous attempts before the war, but they'd failed because of bad weather, which, as astronomers, our mortal enemy are clouds. I don't mind it raining. I just would rather it rain during the week and not on the weekends. But there was also instrument deficiencies as well, and it was on the solar eclipse was going to happen on the 21st of September 1922, and the most favourable site was 80 Mile Beach on the north coast of West Australia. And the party that was involved was a mix of people from England, the US, Canada, India, Perth Observatory, Alexander Ross from UWA, University of Western Australia, the New Zealand government astronomer, JBO Huskings from Melbourne Observatory as well. And they all came to Perth. Billy Hughes, who was our Prime Minister at the time, I believe, basically told the Australian Navy, get to Perth, get them up there, and make sure, and also told all the train services to make sure that they got to Perth as well, because some people were travelling via the train from the east coast to Perth. And so you had all this equipment that once they got to 88 Mile Beach, all this sensitive equipment was then put onto the beach by rickety rowboats. And so, you just couldn't imagine stuff like this happening in the day, but this is what you had to contend with back in 1922. But Michael Durack and the local indigenous people met them there, and they put the equipment on the donkeys, and they went out to the Wallal area station where they did their observations from. And this is the photo. And so what they were looking for was, they were looking to see the light from the background stars being bent by the sun's gravity. There were two types of measurements that you should expect to get. One using Newton's ideas on gravity, and then Einstein's theories. And so when they did the measurements from the glass plates, it was actually the Lick Observatory from the US who was able to use, they were able to find it out. When they used their data, they realized that that general relativity, the theory of relativity, was the correct theory, that Einstein was correct, and that Newton wasn't. It wasn't a big thing, really. It was just that where Newton got to, then Einstein was able to take it and run with it and improve on our theories. And so that was actually found out on once they were able to get back to America, and on the April 1923, they were able to announce to Einstein and to the world that Einstein's theories had been vindicated. So after Howard had resigned in 1940, it was taken up by his assistant, Hyman Spiegel. Now, if you think there's something weird about his eyes, there is. There was a series, we have a series of photos on our wall at the observatory, and Jaime was thought to be a bit of a squinter, and so back in the early days of Photoshop, they photoshopped his eyes. And I've actually seen the original photo, and it's not that bad, but the funny thing is as you walk by his photo, it looks like he's actually looking at you as you walk by and following you. So it's a little bit, it's our creepy haunted house thing for the observatory. But Jaime had a surveying background and really progressed with the rebuilding of the post-war ravaged post-war ravaged observatory. During the World War, there was only about 2 or 3 staff. We provided time for the US Navy as well as the Australian Navy, and the Dutch as well, because we had submarines being launched from Perth to patrol the Indian Ocean, and also up around the top of Australia and Indonesia, or the Dutch East Indies as they were called. And so Jaime was very important in that he rejuvenated the time service, the seismic services as well, so seismology services. He also he helped get people to complete the Astrographic Catalogues, and also restarted the publications of the Royal Astronomical Society. In terms of the catalogues, between 1949 and 53, there was the Edinburgh Perth Observatory, Perth Astrographic Catalogues that were published, and this recorded the position of 139,000 stars. So this was using some of the data that we'd had from the Carte de Ciel project, and finishing it up with some of the Edinburgh Observatory's work as well. So that was a lot of stars and a lot of hard work there. He also helped actively search for new sites for the Perth Observatory. In 1955, we had the Stephenson-Hepburn report that was going to explain out how Perth was going to grow and spread out. And thankfully it spreads north and south because we're in the east, and while we do have a little bit of we have light pollution now, it doesn't really get any worse over time, as bad as if it could. And he also so he was one of the main people to say Bickley, where we are now in the Perth Hills, which is about 35-40 minutes away from the CBD, was the right site. And so in 1963, the observatory was partially closed down, and they actually started demolishing the observatory. And one of the funny things was when they were actually demolishing the dome, the Lowell Telescope was actually in the dome, and he was going through. I think it was Bertrand Harris, his assistant, was going through the rubble and found it. It was like, stop! You're not going to demolish it, with a wrecking ball anymore. You've got to hand demolish it. And they also took the dome off as well. But this was what was going to be built. So we've got Dumas House. Originally, there was actually going to be 5 of these buildings, but only one was ever built. They wanted, with the Hepburn report, they wanted to actually bring all the government departments right next to Parliament House, because where the observatory sits on Mount Eliza, you've got Kings Park on one side and then the State Parliament House on the other side. So having government right next to each other all in all was, they wanted to just be able to better talk to each other and save time as well. Unfortunately for Hyman, or Jaime as we call him, he was really important to the observatory, like all the government astronomers are, but he really pulled it out. Howard did a great job of just keeping the lights on and doing very important work, but Jaime was able to take it and really press forward. Unfortunately, he didn't get to see the end results. Unfortunately, he died very early in 1962, and it was left to Bertrand Harris to take over his work. He'd been Hyman's assistant since 1957, and he became government astronomer straight after. And he stepped into a role when the observatory was it was just about to move, and so there were construction of the buildings were going to be started in 1965 and 1964, and the staff were to move in at the very end of 1965. So you've got the Minister for Works cutting down the very first tree. So actually the clearing of the land started in 1964, and straight after the bulldozers came in. So he did jump out of the way, but you can see by the land was completely cleared by the end of 1964. We had the main building being built, and so construction continued through 1965. It was a little bit late. The staff moved in at the very end of 1965, and the building opened on the 30th of the 9th, officially opened on the 30th of the 9th, 1966 by Premier David Brand. It cost the WA government $600,000 to build the new observatory. The very first dome to actually be built was the Meridian dome, and this was overseen by Bertrand, and this was because we were getting an expedition from the Hamburg Observatory in Germany in 1967, and that expedition revised and enlarged and had a more accurate Meridian catalogue of the southern sky than, and so the Perth 70 Meridian catalogue, which they first did, mapped the position of a further 24,900 stars, so nearly 25,000 stars. In 1967 as well, the Astrographic telescope was brought out from storage. He also worked with the University of Western Australia at a 16-inch telescope for the observatory, which was to be used by their students and also their staff as well. And so once they brought out the Astrographic telescope, they'd actually built the dome here. This slide is sponsored by Kimber's mobile cranes here, and you can the actual dome here is the dome from the original dome, and this is the mechanical chair that is being lifted into the dome. The dome and everything is still there. It's the only astrographic telescope that has its original mount, the original tubes, original lenses, and also the original dome. They're all built for one. And that telescope had been in storage since 1963. Now we have what we're probably most famous for in terms of our domes. The Lowell dome is being built here. In 1968, the Perth Observatory got a call from the Lowell Observatory, who was going to be running NASA's International Planetary Patrol program. Sounds like Justice League or Avengers, but unfortunately we weren't protecting the world from alien invasion or from Thanos, but we were to keep an eye on the night sky. And this project was going to consist of 7 telescopes, and it was designed to collect 35mm photographic data. And Lowell calls up and says, "Hey, would you like a free telescope?" And we said, "Yep, would love it." Now, the reason it had to be built so high was to get above the tree line, but also try and get above the scintillation. Now, scintillation is something that if you, on a really hot day and you look off to it on a street, you can see the rippling of the air. That's scintillation. That's very, very bad for taking observations of the night sky. Even at the night in summer here in Perth, you can get a lot of heat radiating out of the ground. So the higher you are, the better the images will be. And also, our atmosphere acts as a lens. So the higher you go, the better your images are going to be. We also have here the actual dome itself coming along. In 1974, observations were scaled down. There was only three most successful stations that were going to happen from the 7. And in 1976, the program was suspended because of the replacement of space probes. So you had, by that stage, Pioneer had been sent out to the outer solar system, and the Voyagers were being built. So our role in the International Planetary Patrol program of looking at the planets, so really Venus, Mars, Jupiter, Saturn, allowing NASA to have 24-hour access to them, that role was being taken by the Mariners now, and the Pioneer probes and the Voyager probes as well. So we were sent. So there are always going to be times when we're not going to be able to see some of the planets because they'll be on the other side of the solar system. But but while we had them in the sky, we were taking photos of them, and out of this project, 40% of all the images that were actually used for the project came from the observatory, and that was why they weren't. The reason we got the last last set of shots for that project was because we had such good quality, and they actually asked the astronomers here, how much film do you need? Because they were averaging out the usage of the film and sending it out to all the observatories. And we actually told them, no, it's okay, we don't need it. We've got a freezer full of it, or fridge full of it. And they said, how? You guys took the best images. They just assumed we were just going gung-ho, taking photos. But it was just that the astronomers, in that Aussie way of, really, really competent. They were just taking shots. They were waiting for the atmosphere to settle and not be too lensy, or with hot heat pockets going in the atmosphere going through the view. But they were just waiting, and then they'd take that shot, and they didn't waste film. And so, out of that, there's some proving again why strains are very, very good at science. Now, if we have any people who are in OHS, I do have to warn you. The next photo is very full of lots of legal issues, but I assume the statutes of limitations have passed here. But this is the lifting of the dome and putting it on top. So here we have a guy underneath the dome in knee-high socks, short shorts, a tie as well, and short sleeve shirts. We have obviously probably the project manager and a scientist because of the lab coat here. He's probably got the calculator holder as well. We have a person on top of the dome as it's being lifted, and we have a number of families here as well. It was a family occasion to actually see the dome being lifted up. So lots of violations here. OHS wasn't a very big thing back in the day, and some of the stories I've heard from people who worked here, what they got up to was quite interesting. And this is the shot of the observatory back in the 80s of the actual whole site. So we can actually see here, here's the main building. This one here is the what we call the Uni Dome, the University of Western Australia Dome. This is the Transit Meridian Dome here, the Lowell Telescope Dome. This dome right here is the public telescope dome that was built in the 1970s, and also over here was the Astrographic telescope. There's a path from the main building through the trees here, and then you go through here. And and there was a lot of stuff other stuff that Bertrand did. In 1966, he restarted the public tours, and also continued to provide the time and tide services. In 1970, Harris formed a dedicated Perth Observatory Meridian section of the observatory, which resulted in Perth 75 Meridian Catalogue that mapped a further 26,000 stars. He was responsible for getting the 1973 International Astronomers Union symposium held here in Perth. And unfortunately, just like his predecessor, he died very early at the age of 49. This led on and he passed away in 1974. This led to Ivan Nikolov becoming the government astronomer for West Australia. He started as acting government astronomer in 1974, but wasn't officially named government astronomer until 1973. He's got a very interesting history. He actually arrived here in 1964 from Bulgaria. So he actually had to escape the Iron Curtain to get here. And Nikolov also worked with the German Hamburg Observatory Meridian team on Perth 70 catalogue. So he started off with doing the actual Meridians section of the observatory. He'd go on to help with the Perth 83 Meridian catalogue, which also mapped positions of over 12,000 stars. As the equipment was getting better and better and better, we were able to see fainter and fainter and fainter and fainter stars. And these Meridian catalogues were very important, particularly for the space shuttle as well at the very beginning when we didn't have the GPS system. A couple of volunteers who have one of our volunteers who was an employer here went to Kennedy Space Center with one of the former astronomers called Peter Birch, and they were chatting to one of the guys from the space shuttle program, and was talking about that they were from Perth Observatory, and that he realised that actually we would have used some of your catalogues, especially down for the southern hemisphere. So it's always interesting to see who was using the Meridian catalogue data. In 1977, we had what would probably be considered our biggest achievement. We co-discovered the rings of Uranus. So in 1977, the observatory hosted Dr. Bob Millis from the Lowell Observatory, who had actually run the International Planetary Patrol program, and also Perth hosted the NASA's Kuiper Airborne Observatory, and there was going to be a very special event, an occultation. So a star which was called SAO 158687 was going to be passed in front by Uranus. And what that can happen is that if you use a photometer, you can actually work out what the atmosphere is like for Uranus. This was going to be the very first time since Uranus had actually been discovered that this was going to happen, and so this was a very important occasion. And this was about 8 years before Voyager 2 was going to get to Uranus, and even at that it hadn't even left. And there was no actual guarantee that the Voyager probe, or Voyager 2, was going to be allowed to go onto Uranus and Neptune, because Voyager 1 needed to get very good data from the Saturn's moon called Titan. And if it didn't, then Voyager 2 would have to follow by the same path, which would mean it couldn't go onto Uranus and Neptune. So this was a very, very important event. And they'd known this was going to happen since the early 60s. They'd been monitoring the possibility of this happening and where it would happen on the world by taking glass plates throughout the decade, and not just us, but also around the world. And that circle was getting smaller each year, and also the possibility rising of that happening. And so it just happened to be that circle of where you were going to be able to see this event on the globe, on the Earth, was going to happen where Perth was, and also down south. So the reason NASA sent its Kuiper Observatory out there was because they needed to fly the whole route and record the whole event. Because Bob actually fought for us to get to help out, because we did such good work with the International Planetary Patrol program, and that's why he came out. He was going to help the observatory. So at 2 a.m. The astronomers arrived. They had everything set up for 4 p.m. and they were waiting for about, the event wasn't going to happen for about 40 minutes. And 20 minutes in, they get a dip. We're not taking photos. The photometer is making a line graph of the light, how much light's coming from that star. And so what we should see in the 40 minutes is a phased drop, like an analog signal, as Uranus starts to move in front, because Uranus has an atmosphere. If it didn't have an atmosphere, it looked more like a digital signal. It would just drop straight down and then come back up. But we get a spike, and the government astronomer's like, "Oh no, it's the photometer's malfunctioning." They they flip a little mirror so that they can put an eyepiece in, and they have a look, and no, we can still see the star and we can still see Uranus. Take the mirror out, the eyepiece out, flip the mirror so the photometer can get the light, and literally a couple of minutes later, they get another spike. And they go, okay, we've got something here. We don't know what it is, but they actually they get five of these spikes in the data. And then it comes time for the first predicted time for the occultation to begin. and unfortunately we get nothing. We also start getting a little bit of light pollution in the east. Second predicted time comes along, nothing. They're really worried now. Halfway through where the middle point should be, they have to turn off everything because there's just way too much light pollution. It's put down on the board in the observatory as a miss because and this is all being done from the big Lowell Telescope dome. And so Dan Trout, the technician, goes home to have a sleep, catch up on sleep. Bob Millis goes to the airport. Peter Birch, the government astronomer, one of the main astronomers here who was running the telescope, he goes to the hospital. His wife was giving birth to their firstborn. So in 2017, on the anniversary of this discovery of the occultation, he actually gave us an annual summer lecture on this subject and told his son why he wasn't there when he was born. But when Bob got to the airport, he met the astronomers from Cornell Observatory, Cornell University, and they were ecstatic, and they were running out of the plane. Apparently, the pilots were ash-faced because they had to tell the astronomers, "We have to turn back now if you want to get back home." They'd captured the whole entire event. And they came up to Bob and said, "Did you see the moons? Did you see the moons?" So they realised what they must have found was moons on those 5 dips. As each moon on the side went by the star, in front of the star, there was a reduction in light from the star, which called those dips. So they announced to the world that they found moons around Uranus. 2 days later, they get the actual data from the Kuiper Airborne Observatory, and they recorded so much data that they had to go outside the hotel room and roll the actual paper like a tin bin bowling ball down the hallway. And then we rolled out our recorded data, and we realised that there's 5 dips here, and there's 5 dips here on the other side. What happens if you fold the paper up? And what happens is all those lines meet exactly, which means that you don't have moons, you have rings. You can't have 2 objects existing in the same orbit. They'll eventually come together. And so 2 days after that, they had another big press conference saying that we hadn't found moons, but we found rings. And this was also really important because up until that point, only Saturn had rings. And so it was a very big discovery. There's a difference also between the rings. Saturn's is very fine. It's like talcum powder. It's ice and dust and rocky particles. Uranus's rings are like someone's done a half-assed job of bashing up a moon. And so they've just gone bang, 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 bang. Yeah, good enough, and flicked it through. The pieces can be anywhere between 30 centimetres to a couple of metres, and so they're quite chunky. Uranus's they would find another 7 rings around it. Another 6 rings with Voyager 2. And then Hubble's found a further 2 or 3 as well. So and they've also got some ring arcs around Uranus as well. So that was a really important discovery. Also during Ivan's time, we had the Sydney Observatory officially close its doors, but it's now run as part of the Powerhouse Museum with volunteers there. So we became the last government-run observatory. In 1980, we also got the Celestron 14 telescope dome, which was the public viewing dome. And unfortunately, Ivan was forced to retire because he reached the age of 65, which for government employees you have to resign. But he still worked on, and so he retired in 1985, and he died at the age of 93, which is a very good innings, in April 2015. In 1985, we got our next government astronomer, Mike Candy, and he was a comet guy as well. we're really lucky because in 1986 we had Comet Halley coming back in the inner solar system. So he oversaw Perth Observatory playing a really vital role in research of Comet Halley. The comet approached the Earth from the north and went behind the sun and then reappeared in the southern hemisphere. So it wasn't accessible to the northern hemisphere. We had a very similar comet, a little bit like this with Comet McNaught in 2007. We had this glorious comet in the southern hemisphere, and it went around the sun, and it was ready to come back for the northern hemisphere, and it just putted out. So all these really lovely shots of from Comet McNaught are all really from the southern hemisphere. But so with Comet Halley, we were able, the position of the comet was actually taken from the Astrographic telescope that would then use to actually fine tune the positions of the actual comet itself. About 10% of all the images were used by the space probe Giotto, which was the ESA's space probe to the comet. And so the reason this was important to find that position of that comet was we had an armada of spacecraft going there to actually see it. But yeah, it was and really it was really important that 10% of all those positions that was from Earth-based telescopes came from Perth. The very first digital camera was actually used in West Australia for it. The University of Maryland astronomers who came down to Perth Observatory to study the observatory study the comet with our government astronomer, or with our astronomers. They brought the very first digital camera out to West Australia to study the physics. We found out that the rotation of the comet itself was about 20 hours, and also that it had cyanide jets as well. So that's really interesting to find out, but it's it makes a comet already more deadly to humans, even a little bit more deadly. Over the period of time, the night sky tours had stopped, and the observatory was at its highest in 1986. We'd had about 84 staff, and then in 1987, the Minister for Works and Services, Peter Dowdy, who would then become a Premier, asked the Bickley astronomers to justify their research. And their annual budget of $750,000. And unfortunately, we didn't do a good job. Half the staff were made redundant. But in a way to try and keep the observatory running and also providing an income, in 1988, the staff decided to provide night sky tours again, and also do for the public, school groups, and special interest groups again. So you tend to see this issue of us doing public events and then stop doing them, and then we get into trouble, and then to get ourselves out of the trouble, we do the night sky tours again. So it's really important to tell people this is why it's really important to do science outreach, because you're telling people why you need to exist, and also the southern hemisphere sky is amazing, and it really can inspire a lot of people. We also had during this time in the early 1990s the Lowell Telescope dome was equipped with the actual very first digital camera that was built here in West Australia. And it was also automated with the help of academics from Curtin and Murdoch universities, and also University of Western Australia. This made the Lowell Telescope one of the very first telescopes in the southern hemisphere, at least, to be automated. And this enabled us to do minor asteroids and also supernova searches as well. By 1996, we discovered 6 supernova. And we'd also, during this time, established our museum that you'll get to see when you come up, if you come up to the observatory after this coronavirus situation has calmed down. And that was actually the museum was actually developed where the old computer room was for back in the day. It's in the middle of our main office building, and which used to hold this massive big computer. None of these little laptops or anything like that. In 1994, Mike had to retire. So at the end of 1993, so there was a search, and they ended up getting Dr. Jamie Biggs to come back and be the government astronomer of Perth, of West Australia. He'd actually had history with working at NASA, so this was a big catch, and he wanted to bring the West Observatory into the digital age. So out of this we got CCD imaging, so using digital cameras, robotic telescopes as well. Being part of the Department of Environment and Conservation, as it was called back in the time, allowed us to have networking of computers networking computers to remote control telescopes as well. In 1996, we celebrated our centenary, so there was an update here. You can see it's very similar to the original foundation stone. You can see on the top right is the symbols of the constellations, and in the inner circle you can see where the planets are for that time. There is a difference between this symbol and the previous symbol. In between the start of the very beginning of the observatory and now, Pluto had been found, and at that stage was still a planet. So our original foundation stone since 1930 was incorrect, and then in 2006 the original foundation stone ended up being correct again. And the stone was unveiled by our premier then, Richard Court, and that was in the 21st of September 1996. They held an event as well, and to do that, and then we also did a series of car park astronomy nights around the city as well. We also got Dr. Joseph Dolan from NASA's Goddard Flight Center to do the summer lecture, and his talk was on where do stars go to die when they die. In 1996, we also had the Perth Observatory volunteer group set up. And this was the first intake, and Bevan here is still at the still with the volunteer group, and was treasurer for most of that time. In 2001, the observatory became the volunteer group became incorporated as well. So there's about 120 of us now. In 2001, we also got the Asta Celestis donated to us by Ethelwyn Flamsteed Moffat. There's only 10 believed to exist in the world. There was about 200 of them published. This was published by Sir John Flamsteed's and his wife and his assistants. He died halfway through making this. But these were atlas of the sky. So he'd seen a couple of attempts at atlases and noticed that they were wrong. So he wanted to create his own atlas with all the stars you can see from the night sky from Greenwich. And so he started it in 1715. It was published in 1729. This copy had been owned by Keppel Loft, who was an English defence lawyer in the early 19th century, and had to flee to Turin because he was a Jacobite, and also he liked Napoleon. And he's done. When you actually see it, you'll notice the writings and the numbering that he's done. And so we flew out Ethelwyn and the book. She'd had it as a coffee table book for a period of time, and then it was in the attic, and she'd been cleaning out the attic and asked the kids, what are you going to do with it when I die? And they said, oh, we'll probably sell it. And she'd been to the observatory as a child, but was now for a school day tour, but was now living in South Australia. So she wanted to donate it to the observatory, so we flew her out with the book, and we had a big ceremony as well. In 2005, the observatory was also entered on the Register of West Australian Heritage Places as well. And in 2007, we had our very first internet telescope. So this is the RCOP telescope, And if you're in on a night sky tour and you go into what we call the VOF, the Visitors Observing Facility, you'll be able to go and look through the Calvert telescope, and then you might hear some whirling about, and it's the RCOP telescope moving on to its next job. So we have school groups from the Northern Hemisphere using it through the night. We've got people doing research with it, so it's really cool to have. But an end of an era, but also a rebirth. The winds of change were blowing hard. In 2010, official research was finished. It had really been a death by 1,000 cuts, unfortunately, and it hadn't been helped with some financial mismanagement, but unfortunately in that some really good employees lost their jobs, and it wasn't like the money was going to go elsewhere to another department or anything like that. They were looking to move this to the square kilometre array. Now, in optical astronomy, there are the two really good sites are in Hawaii and the Atacama Desert, which was the European Southern Observatory. The Square Kilometre Array is a project, a European project that's being built here in West Australia and also in South Africa. And so there's all these different types of dishes, and when you bring them together, because they're an interferometer, so you bring all that data together, and they act as powerful as a dish, one radio dish that's the size of a square kilometre. And so this is going to be it's going to be on terms with the very best radio telescopes, as in the very finest observational telescopes, and that's because West Australia is is so large. You've got places where you can have radio quiet and places so that you can have these really cool dishes. Ralph Martin ended up becoming the acting government astronomer for that period of time. Jamie was forced to resign in 2010, and Ralph acted as in the director's position as had been called until 2013. From 2009, the volunteer group actually took over the running of the night sky tours. Before then, from 1996 to 2009, we'd just been helping the astronomers. But unfortunately, 3 months for me, I joined in 2014, and 3 months into my being a volunteer at the Christmas party, we were told that the staff were going to get redundancies, and you can't blame them. They worked there for a long period of time, government job, and so there was some really good redundancies there. And Greg Lowe, who you haven't been on a night sky tour if it hasn't been hosted by Greg Lowe. He was the last manager under government rule, and he finished up on the 28th of February 2015. But one of the good things out of that was straight after we found out, the volunteer group found out, the government department, the Department of Parks and Wildlife, came to the volunteer group and said, hey, do you want to run the observatory? And it took literally less than a second to say hell yes. So there were a little bit more formalities of votes with the volunteer group, but yes, there was a lot of us that wanted to run the observatory. So we actually entered into a 1-year community partnership agreements, and DPOR, as we called them back then, was saying, look, if you did a really good job, you'll get a 3 or 4 year extension onto it. If not, well, we can work with you to try and see where we need to improve. And we must, at the end of that first year, they said, look, you got a 9.5 out of 10, because no one's apparently perfect, but they were so happy with us that they gave us a 10-year agreement. So we've got the observatory to at least 2026. But so we do, since taking over the running, we've done public and exclusive night tours which brings in a lot of our income. We also do school day tours from years 3 to 6, and it's based off the national curriculum. And we also do vocation care groups during the holidays. We've kept up with the Star Adoption program, which is an unofficial program, and all the stars can either be seen with the naked eye or at least binoculars. We do guided day tour for groups and clubs as well, and we also do the first sun before the coronavirus situation arose. We were doing first Sunday of the month tours as well of the observatory from between 2 to 4. We go out and we do public talks. So we've had TEDx here. We did a range of winter inspirational talks. We have our annual summer lecture, which is always great. And we've had people like Dr. Stacey Mader, astronomer at large, Dr. Fred Watson, ICRA's Luke Davies, our own Peter Birch, as well as doing these summer lectures. This year we had Katerina Milkovich, who's Dr. Katerina Milkovich, who is working on NASA's InSight lander to Mars and had just released some of its data then. And we also go out to groups and schools as well and do public talks. We do workshops as well, so you can we have astrophotography workshops, Astronomy 101 course as well. We've got internet. We still do official research here, and there's some really exciting stuff that's just happening now. But we still got the Cooke telescope, and also Comspoc have got a telescope here, which is a network of telescopes around the world that look for satellites and space junk, and then that data is sent. Can be then sent on to people like NASA, telecommunication companies, satellite companies like Inmarsat, and that to find out exactly where the dangers are, where their satellites are. We can look at if there's been an event where two satellites hit each other, or a satellite's been taken out because someone's wanted to test their latest missile. Then we can that data can be recorded. It's very important because we've got people on the International Space Station, and if there's a few of these impacts, you can make operating in space very hard to do for a very long time. We also go out to festivals as well. We've got Astrofest, which is going to be which is an annual event. Next one will probably be February 20th, 2021. We've gone and done Perth Science Festival. Unfortunately, that's been cancelled for this year. But we've also do the Supernova Comic-Con convention as well. So we always have a good time there. We've restarted the off-site events. I've been to Albany, Borden, Carnarvon, Geraldton, Hyden, Kalgoorlie, Karratha, Newman, Southern Cross, Tranning, and you just get to be we're able to show everyone in West Australia the night sky. And we've done street side astronomy at the Perth Cultural Centre in the middle of the city. We're doing special events with the Organ Donation and Transplant Foundation at the old Perth Observatory, and we've done stuff with schools and councils as well. We've even done special events as well. We had 2,500 people up for our 120th anniversary and 50 years in Bickley, which was absolutely astounding. I tell you, the beer tasted fantastic at the end of the day. We've participated in ABC Stargazing record attempt back in 2018. We're even part of a record attempt from the city of Kalamunda for the largest astronomy lesson. We do stuff like May the 4th. We've done movie nights and sundown as well. We've had special guests. One of the highlights of my life was getting to meet Dr. Neil deGrasse Tyson, Jerry Griffin, who was the Apollo flight director, and just an amazing guy. We've had Damien Mann, the captain of the Wildcats, and also Sean Redditch up to the observatory as well. We've even had the politicians up. We've had our current governor, he's Kim Beazley, local members, and also state politicians as well. We've even had the fantastic chance to actually live stream the super blue blood moon back in January 2008. And this was completely out of the blue because the time and date had talked to an observatory in New South Wales, and unfortunately in the lead up it was only about a week and out, and there was a bushfire in New South Wales, and storms had taken out the solar panels for the observatory, and one of the Japanese observatories couldn't do it because they were snowed in as well. So we had the equipment, we had the know-how, we just had crappy internet. So Ken, our facilities coordinator, was able to really get everything together, and we had a little 4G wireless router on top of the Astrograph, the Lowell Telescope dome, and that was able to provide us internet so that we could live stream it. We'd done media beforehand, so our website crashed with 2,500 visitors at one time. But this is what we're able to show, and we're able to show it's over 1 million people, and the moon, and from Perth, and we had 150 people on site as well. We had Channel 9, we did radio in Perth, Sydney, Melbourne, Brisbane and Canberra as well. So it was a really, really fantastic event. And because we did such a great job, we were able to do the one in July, which was very, very cold. It was in the middle of the night, and I was really, really freezing for that one. But we were also able to do last year's partial eclipse as well. So the 2018 one got over 3.4 million views, and the partial one actually got over 600,000. But the future's bright. So over the last couple of years, we've tripled the star adoptions. We've had each of the last couple of years, we've had over 10,000 people to the observatory for the night sky tours and winter night tours. We've won the 2017 Volunteering West Australia Organisation of the Year on our first try, and we now have DGR status, so that we can, so people can donate money to us and get tax write-offs on that, and also we can go for grants as well. So it's really important to try and keep this place alive, because it has been such an amazing place for Western Australia. And but thank you very much for listening, and I hope you had a really good time, and thought this was really, really interesting. If you have, once the situation finishes, please come up. It's an amazing night sky we have here, we've got down below, if you want to follow us on social media, we have our links in the description to the Facebook page, Instagram, Twitter, and also Patreon if you want to help donate to the observatory. And if you can give a like to this page and also subscribe, we're going to be doing a lot of these live streams of the night sky and public talks as well. So thank you very much for lasting all this way, and I hope you really enjoyed it, and hopefully we'll see you on at the observatory or on one of these nights, these live streams. Have a great night. Bye.